Lesson 12-1, Simplifying Rational Expressions. And in this lesson, you'll learn to simplify rational expressions and to identify values excluded from the domain of a rational expression. Why is it important? Because you can use rational expressions to solve problems involving physics and chemistry. Let's take a look at this application in physical science. Many bicyclists carry small toolkits in case they need to make adjustments to their bicycles while on the road. A wrench, for example, might be needed to tighten the bolts and keep the seat aligned. The force applied to one end of the wrench is multiplied so that the bolt at the other end of the wrench is made very secure. So a wrench is an example of what we call a simple machine called a lever. In 7-2, you learn that to calculate the mechanical advantage of a lever, to, you of a lever, you find the ratio. To be able to find the mechanical advantage of a lever, you find the ratio of the length of the effort arm, that's your effort arm, to the length of the resistance arm. So the ratio of the effort arm to the ratio of the resistance arm will give you your mechanical advantage. So mechanical advantage is usually expressed as a decimal value. Okay? So the formula for mechanical advantage would be, if this is your fulcrum and this is your lever right here, okay, mechanical advantage will be equal to the length of the effort arm over the length of the resistance arm. Okay? And suppose the total length of the lever is 6 feet. If the resistance arm of the lever is x feet, then the length of the effort arm is 6 minus x feet. Okay, I hope you get that. So the function f of x equals 6 minus x over x represents the mechanical advantage of the lever. Okay, so again, if your resistance arm is 6 feet, okay, and the total of the length is length of the lever is 6 feet. One is x feet. The other one would be 6 minus x. Okay, sounds logical. So the ratio would be 6 minus x over x, or length of effort arm over length of resistance arm. So it represents the mechanical advantage of that lever. So the table and graph at the right represents this function. They illustrate how varying the length of the resistance arm affects the mechanical advantage. Notice that as x increases, the mechanical advantage f of x decreases. So obviously, if x is equal to 0, f of x would be undefined, simply because of commandment number 1. You cannot divide by 0, therefore you cannot have a denominator that is equal to 0. Okay, and that's the reason why it's undefined. If x is 1 and we substitute 1 to our expression right here, okay, so 6 minus 1 all over 1 will give you 5, and so on and so forth. If x is 6, f of x will be equal to 0. And if you graph that function, this is how the function would look like. Okay, so notice that as x increases, the mechanical advantage decreases, okay, rapidly. The expression that defines this function is 6 minus x over x, is an example of a rational expression. Okay, so let's define a rational expression. Rational expression is an algebraic fraction whose numerator and denominator are polynomials. Okay, so in this case, 6 minus x is a polynomial, and also x is a polynomial. Therefore, this is defined as a rational expression. Okay, so f of x equals 6 minus x over x is called what we call a rational expression. And because a rational expression involves division, the denominator may not have a value of 0, just like this one. When we equated x with 0, the entire function was undefined. So in this case, okay, we cannot have the denominator having a value of 0, or else the function would be undefined. So therefore, any values of the variable that result in the denominator of 0 must be excluded from the domain of the variable. And these are called excluded values of the rational expression. Okay, take a look at this one. So for 6 minus x over x, the excluded value for x would be 0, because if x were equal to 0, that would make our function undefined. Okay, let's take a look at another one. Let's say you have 5m plus 3 all over m plus 6. The excluded value for m would be negative 6, because if m were equal to negative 6, negative 6 plus 6 would be equal to 0, and the function would be undefined. And let's take it one step further. So for x squared minus 5 all over x squared minus 5x plus 6, the excluded value would x minus 3. X equals 2 and x equals to 3. Okay? Why is that? Because if you substitute x to 2, you'll find out that, if you substitute x with 2, you'll find out that the denominator will be equal to 0, because this is 2 squared, which is 4, minus 5 times 2, which is 10. So 4 minus 10 would be something like this. So if we get our x now, okay, let's substitute that. If x is equal to 2 in this case, it should be 2 squared minus 5 times 2 plus 6. So this would be 4 minus 10 plus 6. We have negative 6 plus 6, which is equal to 0. And that's the reason why 2 is excluded. And that's the same thing with 3. If we equate x with equal to 3, okay, so if x were equal to 3, in this case, that would be 3 squared minus 5 times 3 plus 6, or 9 minus 15 plus 6, or negative 6 plus 6, which will still be equal to 0. And that's the reason why x should not be equal to 2 and x should not be equal to 3. Those are the excluded values of this rational expression. Okay? Now we'll find out how you find 2 and 3 later on as excluded values. Right now, let's take a look at example number 1. So for each rational expression, state the values of the variable that must be excluded. Remember, we're only looking at the denominator. Right now, we're not looking at the numerator, just the denominator. So what we want to do in this case is we want to exclude the value for which b plus 5 is equal to 0. And if you solve that equation, b plus 5 is equal to 0, and solving for b, okay, we end up with subtracting 5 to both sides, you end up with b equals negative 5. Therefore, the excluded value, okay, of this particular rational expression is that b should not be equal to negative 5. Let's take a look at letter B, r squared plus 32 over r squared plus 9r plus 8. Okay, we exclude the values for which r squared plus 9r plus 8 is equal to 0. And remember what we did in the last chapter to be able to solve that. Okay, we need to factor, okay, using the x method, or power of x. So r squared plus 9r plus 8. And if you use the power of x, okay, you have 8 here, and you have 9. So the values would be 8 and 1. Okay, so if you factor that, okay, this now becomes r plus 1 times r plus 8 equals 0. Using the zero product property, you now have r is equal to negative 1, r equal to negative 8. Therefore, the excluded values of r are negative 1 and negative 8. Those are your excluded values. Okay? Let's take a look at example number 2. Okay? And example number 2, to simplify a rational expression, you must eliminate any common factors of the numerator denominator, just like any fraction that we used before. So to do this, use their greatest common factor, okay, or their GCF. Remember that when you have AB all over AC, that's equal to A over B over C. So therefore a over a is equal to 1. So a over b over ac is equal to 1 times b over c, or b over c only. Okay? So it's very similar to what we talked about when we're simplifying simple fractions. For example, if you have 24, okay, all over 40, to simplify this, we get the prime factorization of 24, which is 2 times 2 times 2 times 3, and 40 is 2 times 2 times 2 times 5. Okay? So we simply, when we simplify these types of fraction, we look at the common factors, and we cancel our common factor. That's a 1, that's a 1, that's a 1, that's a 1. Okay, and we end up with 3/5, right? And that's just an example. And it's very similar how to simplify a rational expression. Let's take a look at example number 2 now. When you have 9x squared or yz all over 24xyz squared, okay, we get the factors of 9x squared, which is 3 times 3, the prime factorization of 9, and then we simply expand x squared y z. Okay, and the same thing with 24. Okay, if you want to get the common factors, so basically you want to do this. Let me expand this so it will be more clear to you. 9x squared yz is the same as 3 times 3 times x times y times z. And in the same manner, when you have 24 xyz, it is the same as 2 times 2 times 3 times x times y times z. And you, next step is to cross cancel your common factors. That's common, you cross those out. Common, common, y, z. And you look at what's left. Okay, on the numerator side, what's left would be 3x. On the denominator side, what's left would be 4. So 3x and 4z. Is there a z on top? Is there? Oh, there's a z squared. That's the reason why. This is a z squared. So therefore, I need to add another z. So therefore, this becomes 4z. Okay. So if you notice, the result is the same. Okay. You get the GCF by simply cross-canceling what we've been doing since 6th grade. And that's how you simplify that rational expression. I think this method is simpler than this method when you look at how to find the GCF. So from there, okay, we simplified it as 3z over 4z. But before you simplify, you need to find the excluded values for 24xyz squared. Again, let me repeat that. Before you start simplifying your rational expressions, you need to find the excluded values. And in this case, what are the values of x, y, and z, which will make our denominator 0? Obviously, okay, x, which is equal to 0, y equal to 0, z will equal to 0 will make our rational expression undefined. Therefore, in this case, our excluded values for x, y, or z will be that all the three variables should not equal 0. Okay? So you can use the same procedure to simplify a rational expression in which the numerator and denominator are polynomials. Okay? So let's use the same procedure. I'm talking about this procedure right here. Okay? This one right here. And let's now simplify, okay, rational expression using polynomials. Okay, so simplify a plus 3 all over a squared plus 4a plus 3 and state the excluded values of a. So before we even simplify that, we need to state the excluded values of a. Okay, that means we go back to factoring. So we want to factor, first and foremost, when you want to find excluded values, you want to factor a squared plus 4a plus 3. Okay, and we use the method x. Okay, multiply the first term and the last term. Okay, this is 3a squared, or simply 3. It's up to you. This will make it more clear in terms of, or clearer in terms of how to find your factors. And this is 4a. So you want to find the products of 3, which will give you a sum of 4. And that's going to be obviously 3a and simply a. 3 times 1 will give you 3, and 3 plus 1 will give you 4. So you notice, since the coefficient is 1, the factored form of a squared plus 4a plus 3 would be 3a, okay? That would be a plus 3 and a plus 1. Okay? So a plus 3 and a plus 1. Or if you want to do it the simpler way, power of x, that would be 3, and that would be 4, and that's with 3 and 1. So a plus 3 and a plus 1, same thing. Okay? From there, we simplify our rational expression. Now that we found the factored form of a squared plus 4a plus 3, we use the zero product property. A plus 3 is equal to 0, and a plus 1 is equal to 0. Therefore, the excluded value would that a should not be equal to negative 3, and a should not be equal to negative 1. So these are our excluded values, a, negative 3, and negative 1. So let's proceed to simplify. So we now have that. This is the factored form of a squared plus 4a plus 3. We factored the denominator. Okay? And then, if you notice, a plus 3 is common to both. So we simply cross cancel a plus 3. Okay? Because a plus 3 over a plus 3 will be equal to 1. Therefore, the simplified form is 1 plus 1 all over a plus 1. Okay? The excluded values, as we talked about, okay, would be negative 1 and negative 3. Okay? So therefore, a cannot equal negative 1 or negative 3. Again, you need to find the excluded values before you simplify your rational expression. Okay, let's take a look at example number 4. So to pry the lid off the paint can, a screwdriver that is 20.5 centimeters long is used as a lever. It is placed so that 0.5 centimeter of its length extends inward from the rim of the can. Okay. Then a force of 5 pounds is applied at the end of the screwdriver. What is the force placed on the lid? Okay. Now, what is the force placed on the lid? So we begin with the let statement. Let S represent the total length of the screwdriver right there. Okay. And let R represent the length that extends inward, okay, from the rim. This is the length of the resistance arm of the screwdriver, that particular length right there. Okay. So if that's the case, if that is the resistance arm, the effort arm would be S minus R, because again, that's the total length S, and the resistance arm is, the length of the resistance arm is R. Therefore, the length of the effort arm represents the length that extends outward from the rim. This is the length of the effort arm, which is S minus R. Then we use the formula, okay, given in the connection, or given at the beginning of the lesson, to write an expression for mechanical advantage. Again, the formula for mechanical advantage is length of effort arm over length of resistance arm. In this case, S minus R all over R. And then evaluate the expression for the given values. So we want to evaluate for the given values using that formula. S is 20.5. minus 0.5, okay, which is the length of our resistance arm, all over R, which is 0.5, okay. Simplify that, we have a mechanical advantage of 40. What does that mean? The mechanical advantage is 40. The force applied on the lid is the product of this number and the force applied at the end of the screwdriver. Okay? So what we would do is we get our 40, multiply it by 5 pounds. That equals 200 pounds. Therefore, the force applied on the lid is 200 pounds. Okay? Now look at this one. The force applied on the lid is 200 pounds. But if you look at, okay, our problem, there's only a force of 5 pounds applied at the end of the screwdriver. So with mechanical advantage, using mechanical advantage, the total force applied, okay, on the lid is 200 pounds. And that's the reason why the can opens quite easily, okay, when using a screwdriver, okay, because it equals to a force of 200 pounds being applied on that lid, okay. And that's the end of our lesson, okay. The secret word for this particular lesson is in and out. The secret word is in and out. Thank you for watching.